Okay, hi everyone. So I'm going to do Lyceum second semester, July 2022, grade 9 Edexcel Mathematics, part 1 paper. Right, I'm doing this for a few of my students, so I thought of sharing it with others as well, so that they can get some use from the effort that I'm putting here. Right, so let's start the paper then. Right, so the first question is here. Now, the question one is from sets. Right. So they have given few numbers, some numbers here, and then from there, they have taken two sets. There are two sets. Set A is odd numbers. So let's see what are odd numbers. And then set B is prime numbers. So I want to, and then from this, they're asking A intersect B. So what's the meaning of intersect? Intersect is the common elements for both A and P. If I draw this, intersection is this area, right? They're looking for this. They're looking for this. And for this one, this is union A and P. So both elements in both A and P. You can show that in this way. Right? So this is, yeah. Right. So this is a graphical representation. Right. So this is union. So this is everything. And here intersection. So the first thing we need to do is, let's attempt question one. A intersect P. The first thing is we need to identify what's in A. So what's in set A? Odd numbers. Odd numbers. First is 3, 5, and then 7, 9, 11. These are the odd numbers in the set. Set A. And the prime numbers are the prime numbers. Prime numbers. I hope you remember what a prime number. The prime numbers are the numbers which you can only divide. So the prime numbers can only be divided by 1 in itself, which is the first one is 2. 2 is a prime. Yeah, 2 is a prime number. It can be divided. So 2 is a prime number, and then 3. And then we have 5. 5 is a prime number. And then 5, 7. 9 is not a prime number, even though it's an odd number. And then we have 11. So these are the prime numbers, right? 2, 3, 7, 11. 3, 5, 7, 11 are the prime numbers. From this lot. Now let's see what's the intersection, the common elements for both set A and P. I see 3 is common, 5 is common, 7 is common, 11 is common. So these are the common numbers. Let's write them. Yeah, that's it. The first thing is done. 3 is common, 5, 7, 11. So this is A intersect P. Is the answer, you get 2 answers. And the union altogether, elements altogether in A and P. So we'll start with the numbers, the elements in order. So we'll start with 2, and then we have 3, and then we have 5. Then we got 7, 9, 11. 11, right? Yeah, those are the ones. Right, then right. 3, 5, 7, 9, 11. Yeah, with 2. These are 2 marks to this one. So A union P is the answer. You can easily get 2 marks to this. Right? Now I'm moving to question number 2. Question number 2 is, let me see, right. Yeah. So we have a Cartesian plane. Yeah. What does it say? On the grid, plot point -3, 2. That's very easy. Very easy 2 marks. -3, 2. -3 and +2. This is A. And then they ask, so this is done. Easy, very easy 2 marks. Write down the coordinates of point B. Write down the coordinates of point B, 2, 3. So this is 2 and 3. So remember, I know this is very basic. So first it's the X coordinate and then it's Y. So we do. So B is done. Another very easy 2 marks anyone can get without a problem. So question number 3, we have a calculation. What does it say? Now in here it says, in the spaces provided, write each number in this calculation. Write each number in this calculation correct to, so we need to correct to first significant figure, correct to first significant. So each number here, each number, so we got 4.8 is 1, and then 1.98276 is the other one, and then we got 16.82. 16.8 is the, let's write it here. Okay, so each of these numbers should be correct to the first significant figure. So when we are now, if you remember what are significant figures, in 4.8 you got 2 significant figures. The first one is 1 SF. This is the second SF, 2 SF. Okay, so second SF. So when you correct to the first significant figure in this question is, you need to correct the first significant figure. So what you need to do is very simple. You just have to cut off from here. So when you do that, you have to see who is behind you. Is 8. So when you are cutting off 8, if that number is 5 or more, you have to round up. Round up means 4 becomes 5, and this 8 becomes 0. So the first number is going to be 4.8 changes to 5. And then here we have first SF, second SF, third, fourth, fifth, sixth. These are the significant numbers. Now I'm going to cut this one according to the question. So I'll be cutting it from here. Because it's 9, I need to round up. 5 or more, you add 1 more. It's round up. So this is going to be 2. The next number we have is 16.82. 16.2, that this is the first significant figure, second significant figure, third. And then, since we have to correct to the first significant figure, we are cutting it from here. This is where we cut it. So it's behind that line is 6. So when you're cutting off 6, is again rounding up. So this one. So 1 becomes 2. All the other numbers turn 0. Right? All the other numbers will turn 0. So that number is 20. 5 times 2 is 10. 10 divided by 20. Answer is half. Right? Answer is half, or 0.5. All right, I put 0.5 here. So that's my answer for question number 3, right? It's done. Very easy, 5 marks. Now we have a vector. What do they say? Write each of the following as a single vector. Right, so we have to multiply vector A by 3. So vector multiplication by a scalar. Very easy. It's going to be like this. So we are multiplying both the elements 3 and 5 by 3. So when we do that, 3 times 3 is 9. 3 times 5 is 15. Here is the answer. Right. Next is A, vector A minus vector B, A minus B. So that's again very simple. So 3 That's the first element 1 1. 3 minus, we have the first element of this one 1 1 is negative 8. See, I have put negative 8 inside this bracket, and then I from there I'm looking at the 2 1. 2 1 is 5 in A, minus, because it's minus, with A minus B minus 7. That's the first step. And then minus and minus plus, so 3 plus 8, and 7 minus, so 5 minus 7 is 2, negative 2, that's negative 2. So this, and 11 and negative 2, sorry. So that's negative 2. This is my final answer for A minus B. Very simple. Yeah, 4 marks. Getting this 4 marks is nothing again. Right, here simplify. So we have two expressions. We have two terms here. We have to multiply them. So here you need to look for your like terms. What are the like terms you see? So I got two numbers here. 6 times 4. Very easy. 6 times 4 is 24. And then on the first term, the first one we have 1u is going to be this. U multiplied by u. U multiplied by u. So when we are multiplying, it's u squared. Here you have 1 power. So when we are multiplying with powers, the powers get added up. So it's u to the power 2, or u squared. And then w. Then we have here w negative 3, power negative 3, w negative 6, positive 6 here. So let's write it here. W negative 3 times w 6, power 6. Now, like I said, so when we are multiplying powers in index form, we can add them, add the powers, add the indices. So negative 3 plus 6 is going to be negative 3 plus positive 3. So this is going to be W3. That's my final answer. Very easy. Another 2 marks. Right. Now question number 6. Calculate AB. Okay, what's AB on this? This is the ABC triangle. This is AB. Okay, this is AB. Right, and they have given the hypotenuse. H is given, and they have given 37. This angle 37. So this is going to be SOHCAHTOA, sine opposite hypotenuse. Okay, it's going to be this ratio. Opposite is this one, opposite side divided by. So that will help. Right, so sine 37, it is going to be sine 37 equals opposite AB divided by the hypotenuse 11.2. So now I need to find what's sine 37. Let me find that out. Sine 37, I'm working on my calculator. 37 is 937. Let me see. Yeah, I got it. The sine 37 is 0.6018. So that's sine 37. I know you know how to use your calculator to find that sine 37. Then this is AB divided by 11.2. Now from here, what you do? Then equation. So I need to move 11.2. To move 11.2, this is what I do. I'm going to multiply both the sides by 11.2. Yeah. If you do something to the right hand side, you have to do the same. to the left hand side. So when you do that, 11.2 can be cut off. So here AB 11.2 times 0.61. So you have to multiply this by 11.2. So you're going to get 6.7403 centimeters as your final answer. So that's done. Question 6 also done. They give you 3 marks. Now let's move to question number 7. The equation of line L is 2x minus 3y equals 6. Find the gradient of L. Gradient I know is m. Gradient means m. And so we have a formula like this. Now, when I look at this, it doesn't look like the generic formula that we know for these sort of lines. What is the generic formula? This is generic formula y equals mx plus c. Does it look like y equals mx? No, it doesn't look. So the line given is not, doesn't look like y equals mx plus c. So this should be changed to this format, the generic format. So y should stay on the left hand side. That means this is going to be negative 3y. And this x will be taken to the other side, negative 2x. So when the positive 2x is taken to the right hand side, will become negative 2x plus 6. The x doesn't move anywhere. Now, does it look like what we have? The generic? Still not, because here is just y. Here is 3y. So, and here is negative 3y. So we don't need any of that. We need positive y on our left hand side. So to get positive y on the left hand side, what can we do? What we're going to do is we're going to divide each of these terms by negative 3. So I'm going to divide each of these by negative 3. Each of these will be divided by negative 3. When you do that, you end up, this is negative divided by negative, negative number divided by the negative number becomes a positive. So 3 divided by 3 is 1. So this here, the left-hand side becomes y, just y. And this negative and negative becomes positive. So it's 2 over 3 or 2/3 of x. And then positive divided by negative value is negative, right? Now we have, so now this thing looks like a generic formula. Can you see? It's y, it looks like y equals mx plus c. Now they are asking the gradient. Gradient, what is gradient over here? Gradient is m. M is the gradient. So that means, do we have something similar to that? Yeah, when we map the generic formula to the real formula, we can see m equals, that's correct, 3 marks. That's not a big question, so that's why they're giving the 3 marks, only 3 marks. Oh yeah. And then part B. So there is a B, part B to this question. Find the equation. Find the equation of the line which is parallel to L. Now L is y equals, so y equals 2/3 of x minus 2. So we need to find a line parallel to this. So when the lines are parallel, the gradients, when the lines are parallel, the gradients are equal. The gradients are equal. When the lines are parallel, gradients are equal. So for that line, for this new line, we are going to have a formula similar to this. Y equals, because we're going to have the same gradient for this x, and then we don't know what c is. That's what we need to find here through the information given in the question. So what's the information given? Find the equation line which is parallel to L and passes through the point. So it says this line, this new line is passing through 6, 9. That means when this line passing through 6, 9 coordinate. So if you say 6, 9, this is the x coordinate, here is the y coordinate. So when x becomes 6, y becomes 9. When x becomes 6, y becomes 6 on that line, right? So then let's apply these coordinates. Let's apply the coordinates into this formula. How do we do that? So y will become 9 when x becomes 6. When x becomes 6, y will become 9. So 9 equals 2/3. So x becomes 6. I'm going to put 6 over here. See. Now I can simplify 6 divided by 3, which is 2. Now I have 9 equals 4 plus c. That means I know, so when I take 4 to this side, c is 5. C is 5. So we can simply write this formula. The required answer is going to be, now let's put c into the formula as well and complete the answer. So y equals 2/3 of x. C is 5. You get 4 marks for doing that. Now I'm moving to question number 8. Solve the simultaneous equations. Okay. Solve the simultaneous. You have simultaneous equation y equals 2x equals 6. Y equals, so what, y plus 2x equals 6. Now I will name this as equation 1, equation 2. Now let's look at these two equations closely to eliminate something. See whether we can eliminate something very easily. Now you have negative 2x or minus 2x plus 2x. I know these two can be easily eliminated if you add these two formulas. So I'm going to add them, and 1 and 2. 1 plus 2. So I'm going to do 1 plus 2. 1 plus 2. So when you do that, left-hand side of 1, I'm going to write left-hand side of 1, y minus 2x. And then the left-hand side plus left-hand side of the equation 2 is y plus 2x equals right-hand side of 1, right-hand side of 2. Now I can see minus 2x plus 2x can be eliminated. Y plus y plus y is 2y equals 6. Now we know y equals 3. Y equals 3. Now I'm going to apply y equals 3. Applying y equals 3 to equation 1. So I'm going to apply y equals 3 to equation 1. So equation y is y equals 2x, y minus 2x equals 6. So y becomes 3 minus 2x equals 6. Now in this case, I'm going to take the x's to this right-hand side and take the numbers to the left-hand side. So when I do that, 2x is going to the right-hand side and the 6 is coming here. So 3, when 6 comes here, this is a positive 6 coming to the left-hand side. It will change to a minus 6. And then when this one, when negative 2x goes to the right-hand side, it's positive 2x. Right? And then 6 minus 3 is negative. That's negative 3, 2x. So x here is equal to 1.5 negative. Y is 3. These are the two answers. Simultaneous equations. So this is giving you 3 marks. Okay. So that's done. Now we can move to question number 9. Question number 9. So let's look at question number 9 quickly. Geometry. Okay. Number 9. Triangle ABC. There is a triangle. Triangle ABC is isosceles and ABC isosceles, and they are showing AC, see here, AC and BC are equal. AC and BC are equal. AC is parallel to BD. So when you, this is showing us that these two lines are equal. That's why they have marked in this way. And AC and BD are parallel. So this is the symbol for parallel lines. Yeah. So AC and BD are parallel. Find the value of A and value of B. Where is A? Okay. So this one is A. This one is B. Right, so these two we need to find. Now, since now we have a triangle, isosceles triangle, these two are equal, this is 40. The rule in isosceles, the fact in the isosceles triangle is, so when you have these two sides equal, you know that this one and this one are equal. That means 180 minus 40, 140 divided by 2 is one of these. So this is 70, this is 70. That means we have found out A is already there, A is 70. And then B, oh, parallel lines. Here is a parallel line, can you see? Is it? This is 40, this is 40, B is 40, why? Alternate angles. Find the value of A and B, so B is 40. A is 70. Right? And the value of A and value of B. So we are done. Now let's move to question 10. Y is directly proportional to the positive square root of y. Y is directly proportional. Directly proportional. What is that? Directly proportional to square root of x. We have y, x, square root of x. Directly proportional, when they say directly proportional, that means when you increase y, square root of x will also increase. It will change in the same direction. When you decrease y, square root of x will also decrease. So that you represent in this way. So it's yeah, like that. That means y can be written as k. I hope you have learned this. Okay, you must have learned this. Y equals k. Right. Now they have given. So this is what you can write. Y equals k. Square root x is what you can write from the information from this line. From this line, you should find this, identify this fact. And then let's say x is 9. X is 9. So we'll put 9 to x. Y is, when x is 9, y is 12. When x is 9, y is 12. When x is 9, y is 12. What does that mean? X will put 9 to that. Y is 12. Okay. When x is 9. Pretty easy. Square root of 9, which we know. Square root of 9 is 3. So 12 equals 3k. Is 3k. That means the letter k, which we found, is 4. Right. Now I can nicely write our relationship between y and square root of x in this way, with after finding out what is k. Right. Y equals k square root of x. Right? So I will write this. I'll put 4 to this one. Y equals 4 square root of x. Now they're asking when x is 1/4. When x is 1/4, to find what is y. X is going to be 1/4. We don't know y in this occasion. Square root of, so x is 1/4. So I'm going to put that. Can we find square root of 1/4? Square root of 1/4 is half. So y equals 4 times. Now the square root goes half. Very easy. Now so y is 2 times 1 is 2. So when x is 1/4, when x is 1/4, y is going to be 2. That's the answer. Right. So we have done that. And now I'm taking you to question number 11. Okay. 2 to the power r equals 1/16. Right, 1/16. Okay. Now this looks confusing. What does it mean? This looks confusing to me. Right. Okay. ISO 16 can be written as 16 can be written as. Now you need to remember. So when you look at these numbers, these things should come into your mind. See what I'm going to write here. 2r equals 1. So 16, my 16 is 2 to the power 4. How do I know it for sure? 2, let's see. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 2 to the power 4. So that's 2r equals 2 to the power 4. And also, now I can take this. Now this is in index form. I can take the base up, which is 2 equals 2 to the power -4. The power came up, became negative. Now, 2, same basis, r is -4, r is -4, 3 marks. Not a big calculation, so that's why it's 3 marks. Find the value of t. Find the value of t. Okay. Now, so here, you must have familiar with this one. So this one is 1/5 of the power 3. Right? So 1/5 of the power. So when you write something like this, which equals, you can write this in index form as, there you go. So you can write it that way. 1/5 of the power. Right? Which means I would write it that way. 3t equals 3, same base, 1/5. Now, t is 1/5. Okay, now we're just mapping. This one equals this one. So t equals 1/5. They're asking what's t. Now, for square root, just a small extension just to remind this. Now, usually for the square root, we don't put 2, but it's 2. We usually don't put the square root for 2. Now, when it's 5, 1/5. Now, this can be written as this. We know 4 can be written as 2 to the power 2 times half. This is going to be just 2. So you don't care, so you get the same answer. So now this is done. The answer. Right? So remember, so whenever you see something like this, so even if you see 6 here and 5, this means 5 to the power 1 6. Okay, done. That's a small recap for you. Now, question number 12. Right. Here it says, question number 2, by shading the unwanted regions, we have to shade the unwanted regions of the grid, find and label region R that satisfy the following 4 inequalities. Now they have given 4 inequalities. Look here. So we need to find the area which satisfies the following 4 inequalities. So that's what we need. So they have given 1, 2, 3, 4, all these 4 lines. Right? Now I can identify y equals 2 line. Where is y equals 2 line? Y. Okay, this is the y equals 2 line. It's y equals y. Why do I say it's y equals 2? So any point on this line, the y coordinate is 2. You see, this is 1, 2, 2, 2, 4, 2, anything. So that's y equals 2. 4 line is there. And then they have given y equals 1 line as well, which is this one. And they have given y equals 2x minus 1. 2x minus 1 is easy to identify. 2x minus 1 is this line. So how did I identify? They have given this line, and this one. So from this, it's very easy to identify. Now, this line has a positive. This line has a positive gradient. So we only got this one and this one. So this one has a negative gradient. So this should be the one, y equals 2x minus 1. Also, y coordinate, the y-intercept here is -1, is going through -1. So I'm sure y equals 2x. So then we only got one more left, which is this one, this line, y equals 5 minus x. Now, how do we identify? So we need to shade the unwanted. We need to shade the unwanted. Let's shade the unwanted areas. Let's look at this one first. Y equals 2 line. Y equals 2. So here, according to this, they are saying all the y coordinates should be less than 2. The y coordinate should be less than 2. Y coordinates are less than or equal to 2. So here, if you go this way, if you go up here, this one, the y coordinate is 3. This is more than. So that means the unwanted area for this, from this, about the region about this. Yeah, the region above this line. And then y equals 1. Let's look at y. So y coordinates are bigger than 1. Y coordinates are bigger than 1. From these lines, this is y equals 1. So all the y coordinates are bigger than 1 is this area. So the unwanted area is when the y coordinates is smaller than 1. So that's for this one. For this one, I'm drawing. I'm just coloring the area for this. Okay. So it's done. So 2 is done. And now y equals 2x minus 1, which is this line. Well, let me take another color. So it's this line. So we are going to talk about this line now. They are telling y coordinates are less than 2x minus 1. Y coordinates are less than 2x minus 1. I'm going to pick. I'm going to pick the coordinate. So we have now, see this red line, I have 2 areas. Now 2 two sections dividing this plane, right? The Cartesian plane. So one side is this, the other side is this. Top of the line, bottom of the line, below that. Okay. Now let's see. Now I'm going to pick a coordinate on top of the line, just picking something. So this coordinate is what? 1, 3. 1, 3. When x is 1, 3. Now let's see whether 1, 3, coordinate 1, 3 satisfied this condition. So y coordinates has to be less than 2x minus 1. Let's see. 2x minus 1. So for this coordinate, y is 3. Let's see. And 2x, where's x? X is 1, 2x is 2, minus 1, 2 minus 1 is 1, 3, oh, 1 less than, oh, that's not right. So this is the unwanted area, because according to this condition they have given, according to this condition they have given, the y's should be less than, y should be less than, so left hand side should be less than the right hand side, left hand side should be less than. Now here less than will be bigger. That means this is the unwanted area. I'm going to color this area. All the coordinates above that line is unwanted. Is unwanted. Right? Now we got one more to go. Y equals 5x, y equals 5 minus x. Y equals 5 minus x. So let's see that. Y equals 5 minus x. Oh, this is less than or equal again. Less than or equal. Now, this is, where is the line? Ah, here is the line. Here's the line. So we have two regions. I'm going to take the coordinate something like this, and let's see whether that coordinate falls into this one. Right? So so this coordinate is 4, 2, 4, 2. When so coordinate 4, 2. Okay, I'm going to put 4, 2 into the line inequality. Right? So when x becomes 4, y is 2. So let's put 2 this time 5 minus x is 4 here. This is 1. So 1 is greater than 2. That means this is also outside the area this is unwanted area. So that is unwanted area. So I can color top of this line. It's unwanted. Okay. Now when you see, oh, now from that, so now we have done everything. Now let's see where we haven't colored. Now if you can see the area here, where is the area? Is untouched. Is untouched. Can you see? This is find and so by shading unwanted, so we have shaded all the unwanted areas. By shading unwanted regions agreed, find and label the region R that satisfies. So region R satisfies. So that little trapezium satisfies this condition. So this is what you need to do. So they will give you 4 marks. Quite a bit of work. You get 4 marks there, right? Okay, so that's also done. I'll go to number 13. Question number 13. Okay, a lot of writing here. Question number 13. Correct to the nearest millimeter. Correct to the nearest millimeter. The length of a side of a rectangle The hexagon, so this is a hexagon, is 3.6. Okay. The hexagon has 3 sides. So it has 6 sides. So one side is 3.6, is it? Regular hexagon is 3.6. Correct to the nearest millimeter. Calculate the upper bound for the perimeter of the regular hexagon. So when you know the side, like many of you will do this. So you know one side, so the perimeter is the length around this shape. That means so you have 3 sides, it's going to be 3.6 times 6, whatever. Right? However, it's not that they're asking the upper bound. Upper bound, because this 3.6 is a corrected figure. They have corrected nearest millimeter. They have corrected it to the nearest millimeter. That means, what does that mean? So let's look at 3.6 again. So this is 3.6 is in centimeter. So the millimeter is 1/10. That means, so they have corrected from here. They have cut off everything after the 6, right? So for you to get this 6, right? For you to get a 6 for this, if you had if it was 3.5, if it was if it was a figure something like this, see, look at this, 3.55, something like this. Then when you cut off from here, because this is 5, it becomes, well, it could be 3.5. Oh, and they're talking about the upper bound. Right? It's 3.5 is one option. And right, so if it was 3.5 something, then still you get 3.6 after correcting nearest millimeter. Did you have anything else? As 3.5 becomes this. Oh, how about 3.64? 3.64 will also give you this. 3.64 will also give you. So when you cut it off from here, when you're correcting from here, so 3.64. So the side could have been 3.64 something. Then still, this becomes, when you correct it, it becomes. So I would put 3.65. Okay, so this could have been this, or it could have been 3.65. I'm taking the upper, so anything below 3.65 would satisfy that. So they are asking the upper bound, the biggest. Now the side could have been 3.55, or it could have been 3.65. So when you want to find the upper bound of the perimeter, then we pick the upper bound of the length, upper bound of the side length. So upper bound, so this is the lower bound. Look here, this is the lower, this is smaller, this is upper bound. We are taking this one, 3.65. So that means we are not going to do this. Instead, we are going to put 3.65 times 6 will give you the answer. Let's see what's 3.65 times 6. 3.65 times 6. equals 21.9 centimeters. Yeah, this is 21.9 centimeter. Calculate the upper bound for the perimeter. So upper bound. So we did not take this one. We took the upper bound. Upper bound is this. So that's the upper bound. So the perimeter of this hexagon is always below 21.9. That's the highest it can go. It's the highest it can go. It has to be lower than this. Okay, that part is done. Now let's do part B. Yeah, that all that effort deserves 3 points. Yes. Then they're asking, clearing this off so that I can see the next question clearly. Right. So the next question here is correct. Correct one significant figure. Correct one significant figure. The area of the rectangle, 80 square centimeters. Okay. So area of the rectangle is 80 square centimeters, which is correct in the first significant. And then correct two significant figures. Correct two significant figures. The length of the rectangle is 12. Calculate the lower bound. Calculate the lower bound width of the rectangle. So calculate the lower bound width of the rectangle. Let's see. Okay, lower bound width. Okay, so they have given the area. Now let's see what a rectangle. See the rectangle and 80 is the area. They have given the length and then they're asking the width. However, now these figures 80 and 12, they are corrected figures. Now they are asking, now how, so if this is the case, how are we going to find the width? The way you find the width is, now we have area equals length times width. So we, and then when you want to find width, so it's area divided by length, width. Right? Now here, however, it's not simple calculation. So what they're asking is that they're asking us to give us the lower bound of the width. Oh, lower bound of the width. Lower bound of the width. How do we find lower bound of the width? If you want, so width has to the smallest possible width. Smallest possible width. That's what they're asking. Smallest possible width. How do we find the smallest possible width? Then, if you want to find the smallest possible width, then the area should also be the smallest possible because this is the dividend. Okay. So lower bound of area and divisor has to be the biggest. Right? So when you divide it by a bigger number, this should be the upper bound. Okay, now we need to find upper bound, so lower bound of the area, upper bound of the length, which will give us the answer. Now let's look at, so our area is 80 after correcting to first significant. Correcting to first significant figure means when they were doing it, they have cut it off. They have cut it off from here. So when you cut it off from here, this could have been either 75 or 85. If it's 85, this becomes 9, so it's 84.9999, something like that, right? So when it's, if it was 75, if it's 75, because we need to get the lower bound. So lower bound, so So 80 lies between 75 and 85. It lies between 75 and 85. So that lower bound of area is 75. Yes. So lower bound of area is 75. We found one. Next, we have to find the upper bound of length. Now let's look at length. What is length? Length is 12. Length is 12. This had been corrected to two significant figures. It has been corrected to two significant. So length has been corrected to two significant figures. That means they have cut it from here. They have cut it from here. So it had been 12 point, could have been 12 point what? 12.4999. So let's say you put 4 here. If you put 4, when you cut from here, still be 12. Yeah. So the upper bound is 12.5. Right. And then lower bound for this one is going to be 11.5. Why? This could have been 11.5. Why is it 11.5? Because when you cut from here, because this is 5, this becomes 12. So the answer you get is 12. So the two bounds for 12 is 11.5 and 12.5. So 12 lies between 11 and 12.5. So here we need the upper bound. So biggest length is 12.5. So let's take 12.5. So this is 75 divided by 12.5 will give us the what? Lower bound of the width. Let's do that and see. 75 divided by 12.5 is 8. Oh, sorry, it's 6. Yeah. Equals 6, which is the lower bound of the width. Done. Number 13 is done. So rotation next. To clear all this, try. Okay, so whenever you need, then you can post the video and you can go through it. Right, now it's question number 14. We are doing this. What does it say? Describe fully the single transformation that maps P into shape Q. So P has come to Q. What was the transformation? Right, this is a transition, right? They have just pushed it. P was pushed to Q. Okay, the sizes haven't changed. The rotation, if they haven't rotated, it is just a push. So what's this translation? This is how you do. So we just compare two, we just map 2 points and see what has happened to these points. Okay. So let me take this point and this point. Okay. So you have to map to the correct point, because you can't map this point and this point. That's not the correct one. So if you map this one, you'll have to take this. Is that right? It's clear. So I'm going to map the tip. What's the coordinate here? Coordinate here is -3, 1. Here is 2, -3. Now let's see what has happened. Right? What has happened? I write like this. 2, -3. Now see, now it's very easy to see. What has happened was this x coordinates has moved from -3 to 2. So it's a plus 5. It's a plus 5. Yeah. And then this y coordinate has reduced. It's come down from 1 to -3. So this is a -4 for movement. -4. 1 minus 4 is -3. Right. So this translation is, so this is a transition by 5 by 5 minus 4 vector. That's what has happened here. Okay, that's how it has transformed. Now they are saying, so this gives you 2 marks. It's very easy. You just have to compare the 2 coordinates, then you can get this one because it hasn't been rotated. It's very easy. Now in question B, they are asking us to rotate the shape 90 degrees to clockwise. When you rotate 90, so it's going to come to this one, right? It's going to come to this. So rotate 90 clockwise about the point 10. About the point 10. What is that? I'm also getting confused now. 10. 10 is this? 10, yeah. About the point 10. So they're asking to rotate it clockwise. Now, if you hold it here, yeah, if you keep the finger here and you rotate the shape by a 90 degree by keeping on this, right? Sticking onto this. If you rotate this shape, if you turn a 90 degree, what will happen? Okay, I think now if you move a 90, so from here, so we are keeping your finger here. You rotate a 90 degree. You're rotating a 90 degree. So when you do that, right? So I think, how is it going to look? Right? So this one is turning a 90, right? Yeah, turns a 90. I think this point comes here. Is it going to be like this? Hmm? It looks like this. Yeah, I think it's this. What do you say? You turn. Yeah, so this stick will go here. Yeah, because you're rotating from this one. Yeah, this is how it goes. Yeah, I think this is the one. That's done. So this part is done. Let's move. The diagram shows a circle with center O. The point ABC lies on the circle. ABC lies on the circle. AOB, AOB, AOB. It's 96. Work out the size of AC. That's very simple. Size of ACB. So this is half of this. 96 divided by 2. That's 48. Right? So the angle made by this segment is half of the angle is made on the center. That's 48. Okay, is done. Work out the radius of the circle. Oh, radius of the circle. How do that? Work out the radius of the circle. You get 2 more marks. You get 5 marks. Yeah. Okay. Radius of the circle. Radius is this. Right. Now we have to, okay, this is an isosceles triangle. Yeah, this is what's going to happen. Now, if I draw a perpendicular to AB, AB divides in half. So this part here is 8 because it's 16. So this is 8, right? And this is a what? Right angle triangle. This is 8. And now I know since this is a isosceles triangle, I can find angle A and angle B. 180 minus 96 is 104. No, what? 180 minus 96 is 84, is it? Yeah, 84. 84. Divide by 2, 47, right? 47. So angle A is, this is 47. This is also 47. Zoom out. Right? So this one is 47. This one also 47. Angle A and B. So now they are asking this radius R, AO. Now we have an angle. We have this one. Adjacent side. SOHCAHTOA. I think we can use that. TOA. Opposite adjacent. No. What do we need to do to find R? Cos, right? Cos 47, isn't it? Yeah, cos 47 is what we need. Cos 47 ratio can be used to find that. Cos 47 ratio is adjacent side. Adjacent side here is this one. This is adjacent side, which is 8, half of 16, divided by the radius. We don't know the radius. Now let's find cos 47. Let me find cos 47. Cos 47 is 0.68162. Let's say that was 8 divided by R. So you take R to this side, 8 divided by 0.6820. And then now you can find easily R. Let me find using my calculator here. 8 divided by this equals, is it 11.7? I think that you can work it out and see. 11.73 centimeters. 1.73 centimeters. Okay. That's R. Okay. Right. I don't know if you need a recap on this. So what I did, so they were asking this. They were asking to find the radius. I have to find the radius. Okay. To find the radius. Now, since this is an isosceles triangle, now I found out that this one is 47. This one also 47. Right? Because angles in a triangle add up to 180. So when A and B are equal, so this is 47, 47, and the top one is 96. Now, since it is an isosceles triangle, if you draw a perpendicular that divides and AB in half, this becomes 90, and so this is 8, and we need this one, our radius is this. So using the cos formula, the cos ratio, cos 47 is adjacent side divided by the adjacent side is 8 divided by the hypotenuse, which is r, to give you that. So that's how it's done. Yeah, so this is done. If you answer correct to three significant, do I have three significant figures? Yeah, so if you give the answer to three significant figures, that means you need to cut it off from here. It's going to be, so it's 3. You don't have to worry. So it's going to be 11.7, I think. Yeah, centimeters. Now let's do 16. What does it say? Town B is 35 kilometers east. Town B is 35 north of town A. Town B, so they're talking about, so from A, they're telling the bearing, right? From A, town B is 35 east and 80 to north. 35 to east, 80 to north. Work out the bearing of A, bearing of A from B. Bearing of, so we have to look at the bearing of A from B. That means if you draw the north line from B, you need to find this one. You need to find this angle. So how do you find that angle? How do we find that angle? Okay, so do you know this one is 180 plus something? We'll give you that. Angle, let me say is theta. We have 10. Yeah, so we have to take opposite and adjacent. Okay, the 10 ratio is going to use here. So tan theta, this angle, so this angle is theta, which is named as theta, equals SOHCAHTOA. Yeah, opposite divided by the adjacent. Opposite is 35. See, look to this triangle, this is the opposite triangle. 35 divided by 80. So tan theta is going to give you, now let's do 35 divided by 80, right? 35 divided by 80. Divided by 80 is giving you as 0 0.4, 0 0.4375. 4375 theta. Now you need to find tan inverse and find what theta is. Right? I hope you know how to do. Go back. Tan inverse. Hope you know how to do it. I'm trying to do it from my calculator. Tan inverse 0.4 0.4375 Yeah. It's going to equal to, okay. So this theta is, this angle theta is 23,629, something like that. So give your answer correct to the nearest degree. Give your answer correct to the nearest degree. So this theta can be, so when you correct the nearest degree, it's 24. Theta becomes 24 after correcting to the nearest degree, because you're cutting off from here. So this theta is 24. This whole thing is 180. The bearing of A from B is 180 plus 24. What's that? 4. So 204. Okay. That is rule number 17. So we got 3 more to do. The straight line L passes through the points -2, 3, and 6, 9. Find the equation of the line that is parallel and passes through the point. Okay. Now they have given a line coordinates. Okay. This one, -2, 3, and this one is 6 and 9. So with this information, what we can find is we can find the gradient. We can find the gradient of this line. Okay. Why do we need the gradient of the line? So because they are asking for a parallel line to this line. Okay, so let's find the gradient. Gradient is change in y divided by change in x. First change in y, so this 9 minus 3 is change in y. It's 9, 3 divided by change in x, 6 minus 2. 6, 8. The gradient is this one. Okay. Right. We have found the gradient now. So now they are asking an equation parallel to this. So our generic equation is mx plus c. Now I can write m as x plus c. Now the matter is to find c. To find that, they are saying that that parallel line is passing through point 5, -1. So if you apply x's and y's into this the equation that we have found, we can find what c. So let's say y equals -1, 3 divided by 4, x is 6. Oh, sorry, x is 5. I'm sorry. X is 5 plus c. Right, so it's -1. So -1 equals 15 divided by 4 plus c. Now we need to find c. Yeah, so I'm going to write somewhere here. Okay. So to find c, -1 minus 15 c is going to be a negative number. It will be a negative number. This is correct. Is my gradient correct? Because it's odd numbers. That's why I'm choosing this. I just want to see whether my gradient is correct. Changing y, 9 minus 3, that's correct. 9 minus 3 is correct. And 6 minus 2. 6 minus 2. Okay, that's correct. And then y big. Okay, so that's correct. Nothing to do. So for this one, So if I simplify this negative minus 19 divided by 4 equals C. Right, so we have the gradient, we have the y-intercept. Now it's a matter of putting them into this one, y equals mx. So okay, y equals plus c. Now I'm just gonna put c 19 over 4 over 19. Sorry, so 19 over 4 minus 19 over 4, right? And then right, so then also, so that's the formula, but they want it in this form, ax by plus c. Right, so you don't want, so they're not asking anything in fraction. I mean, this is okay. Yeah, so they're not asking anything as fractions. So what I'm going to do is, just to get rid of these fractions, I'm going to multiply everything by 4. I'm going to multiply all these by 4. All of these terms by 4. By 4. So when you do that, I can cut these things off. So then it's 4y equals 3x minus 19. So still they're asking ax plus by, okay, by equals c. Okay, ax. So okay. So this is going to, I'm going to take y to the right hand side. So when you do that, 3x minus 4y, and c will go to the other side. So c will become positive 19. Positive 19. So this is the answer. In the way they have asked. So 3x minus 4y equals 19 is the one. So that's done. Yeah, a lot of working. Let's clear this out. I got 2 more to cover. Yeah, it took a lot of time. Right, this is very simple. 18th question is quite simple. Simplify, leave your answer in index form. So you just have to 6. You have to add 5 plus 2 plus 1, which is 6 to the power 8. This one is going to be 9 to the power 14 because this power of power. So you might 7 times 2 is 19. Right, find the value of n. They're asking the value of n. So for the first one, 5n plus 3 divided by 5 to the power 6 equals 5 to the power 4, something like that. Right. Now, I think I can take this 5 to the power 6 up, then it becomes so I'm going to multiply both sides by 5 to the power 6. See what this one I'm going to do this. So when you do that, 5n plus 3 equals 5 to the power 10. Same base here. That means the powers, so n plus 3 equals 10, and n is 7. So if n plus 3 equals 10, n is 7. That's also done. Okay, solve the simultaneous equations in question 19. You must show all your work. All your work is okay. You have to show all the workings. How do we do this? Okay. Solve the simultaneous equation. Mm, okay, let's say this one 1. I'm just seeing this for the first time as well. Right. What I would do is, right, I would do this. I will do 1 minus 2. Let's see 1 minus 2 what happens, yeah? Uh, right. 1 minus 2, so y minus y, that's 0. 5 minus 9, and then this is minus 2 or minus 4x minus 1, because I'm subtracting 4x plus 1 from this. Right, so when you do this is 0, 5x to the power 2. This is 4x. So this plus 4x minus 4x you can cut off. Minus 9, minus 10. Yeah. So 10 equals 5 squared. 2 equals x squared. Yeah. Which is right. Yeah. So right. So this here, let me just check because you don't get a so the square root of x is equals minus. Okay, there's a bit of a problem here in this question. So this is not 9, this is 19. It should be 19. It is 19. Right? It's not 9, it's 19 minus 19. So 5x squared plus 4x minus 19. And then you minus 4x minus 1. So then 19 minus 1 is 20. I was just checking. I went back and checked the paper. So it was 19, it's not 9. Printing mistake on this, right? So then, so this is 20. Yeah, so this minus 20 when you take it to the left-hand side is, and then 5 divided by 20 is going to be 4. This is 4. Right? So then square root of 4. Square root of 4 is what? Plus or minus 2. So x is either minus 2 or x is either plus 2. So then we need to find, so x has two values, x equals minus 2 or plus 2. So now we have to apply to the equation 2. So I'm going to applying to equation 2. So my equation 2 is 4x plus 1. If I apply x equals minus 2, x equals minus 2. So y, then let's see what's going to happen to y. 4 minus 2 plus 1, y equals minus 8 plus 1. So y equals minus 7. So that's negative 7. When x equals minus 2 is minus 7. So now I'm going to apply x plus 2 to this one. So when to the same equation, I'm going to apply x plus 2. When it's plus 2, this is plus. So this is positive 8. Positive 8 plus 1 is 9. So this is going to be 9. Right, so that's done. So x is either -2 and y is -7. When x is -2, y is -7. When x equals 2, y equals +9. So that's 19th question. We are done. And then OABC is a parallelogram. OABC is a parallelogram. BCD is a straight line. BCD is a straight line. BD equals BD can this one. BC. Okay, done. M is the midpoint of OC pole. Okay. OA is X. I can see that. AB is Y. That's visible. Find in terms of X and Y AM. So they are asking AM. AM. These are vectors. AM. So how do I find AM? AM. Right. Hope you know this. AM equals AO plus OM. Right? That's the theory. That's how we add vectors in a triangle. Right? So see, look here, this O and this O. What of them is there? Okay. This AM. That's how you look. So we need to find what's AM using X and Y. So AO, do we know AO? AO, OA is X. So when AO is negative, X plus. Do we know OM? OM is, so this is a parallelogram since OM is Y divided by 2. Done. So AM is this. It's the answer. Now they're asking OD. OD, what's that? OD, this is the one. Okay, so we'll write the same expression similar to what we did before for AM, OD. So if you want to find OD, I'll get in color. OD equals OD, OC. Okay, we have OC. We can get OC, not a problem. OC plus CD. See, C and C facing each other, so this becomes OD. Yeah, that's how we write it. Now do we know OC? Yes, we know OC. OC is Y. OC, CAB is Y. So OC also Y. CD, do we know CD? CD is this one. Get to here. How do you find that? Right. We know BC is X. BC is X because this is X. So BC is X. And now they have given BD as, so here it says BD. Now look at this information they have given. Here it says BD equals 3BC. Okay, do we know? Okay, so BD equals, so BC is X, 3X. So BD is 3X. That means BD is 3X. That means CD is 2X. Look here, BD is 3X. So this one is 2X. Right, so that's done. However, CD, okay, this X is to this side, right? So this is 2X to this side, right? It's positive 2X is this way. So when it's CD, it's minus 2X. CD is minus, it's not, because BC is 2X, because look here, now this one, this vector X is to this direction. So all these are positive to this direction. See, these are positive figures, right? So this CD is minus 2x. So this is y minus 2x. So OD is my y minus 2x. Done. So A, M, and OD is done. And then use your answer in 1 and 2 to write down two different geometric facts about line AM, lines AM and OD. Okay. Shall we write this AM and OD and see what happens? So AM is what? Minus x plus y divided by 2. AB, right? In sorry, AM, sorry. AM. Now OD, I write this together, y minus 2x. Y minus 2x. Okay. Right. I'll change the order of AM. Okay. I will put y divided by 2 minus x. Right. Y divided by 2 minus x. So why the reason that why I changed the order is just to compare. It's easy to compare. Now I can see when I see if I multiply this by 2, what will happen? If I multiply this by 2, yeah, it becomes OD. Right? If I multiply this, so that means 2 AM is equal to OD. 2M equals to 8 OD. 2 AM equals to OD. So what we can write is the geometry. So they're asking a geometrical fact about AM and OD. So AM, so half of AM equals to OD equals half of AM. So that's 1. And then the other fact we can write about this is AM and OD are parallel. These two are parallel, right? I hope you have learned that as well. So when you have two vectors in this form, yeah, they're parallel, right? So this is the end. I'm ending. So we have done all the questions in this paper, and I wish you all the best for your exams. I hope you get good marks, and I hope this recording will also help you for the exam. It's coming up next week. Okay, so I'm going to stop here now. So all the best to you.